Index selection, topics, optimizer selection criteria, when the indexes slow the access down, and index statistics. Let's cover the second piece first. The idea behind indexes slowing access down. That will drive a few people crazy, but here's the short version. At update time, which is to say insert, update, or delete. If we're inserting a row and we've got 100 indexes on this table, then we need to insert entries into all 100 indexes. If we're doing an update causing the row to be moved, we have to modify 100 indexes. If we are going to be doing a delete, we have to modify 100 indexes. Clearly, it is more work to modify 100 indexes than it is to modify 5 indexes. Somewhere in there, you get a gray line where you hit a diminishing point of returns on the value you get out of the index versus the cost at update time. This, by the way, is also a reason a lot of companies have an OLTP server and then they mirror or replicate off to a DSS server so that the replicate or the mirror can have more, actually usually not a mirror, the replicate can have more indexes than the source. I had a company call me, it was a few years ago now, with a hey Jeffrey, can you help me? And this was a company out on eastern Long Island. They called and they said, hey Jeff, our inserts are taking us 3 to 5 seconds. And I asked, who are you? And they told me, and I said, well, how did you get my number? I mean, I always want to find out where people find me from. And it's always somebody told me that you can fix my problem, and it's rarely, I'd say less than a third of the time do I find out who recommended me, which is kind of sad because I always like to send a bottle of wine to say thanks when folks recommend me. But in this case, I did not find out who recommended me. I did hear the story, and they said, our inserts are taking 3 to 5 seconds. First thing I asked was, what else is going on at the time? And they're saying, nothing. This is happening in isolation. My next question was, what's the trigger doing that's on the table? Now, this was late on a Friday afternoon, which is when I get most of my calls, and I wasn't particularly politically correct. I just said, what's the trigger doing that's on the table? And they said, how do I find out if I have a trigger on my table? So I thought to myself, there's your first problem. Showed them how to look, and there was no trigger on the table. My next question was, how many indexes do you have on the table? Their answer was, how do I find out? And it turned out they had over 110 indexes. I think it was 113 indexes on that one particular table. Those of you who are not whistling in impressive exclamation to yourselves probably haven't tried to update a table that had 110 indexes on it. My response to them, your performance is pretty good. They had older hardware. They had 7,200 RPM disks. They did not have any kind of a SAN. This was a very expensive update to be performing. The interesting thing was they only had 30 columns on the table. So my guess at the time was they had at least 80 too many indexes, although probably about 90 to 100 too many indexes. Index statistics and usage, we will talk about how the optimizer decides whether a particular index will be useful and why. So, during the index selection phase of optimization, the optimizer decides which, if any, indexes best resolve the query. Ray mentioned that this is a piece of a class that we do. This is about I think it's about the 6th chapter in. We talk about maybe the 5th chapter in, and we talk about what the optimizer does, what the server does, how it processes queries, and what happens when things come across the line. So we talked about the index selection phase of optimization. There are multiple phases of optimization. This is the one that we're caring about for this particular section. So the DBMS, the optimizer, determines which indexes match the where clauses and match the join clauses. If they do not match the where clauses and the join clauses, the index is not going to be useful. If I say bring back everything that's older than 70 days and I only have an index on last name, that index is not going to be useful. We estimate rows returned and we estimate page reads. Why do we do this? The rows and pages become much more interesting when we're discerning join order, and we'll do that in a future webinar. Some of you may have seen my presentation at the SQL Saturday in Orlando this past weekend. That's what we talked about. But the other thing we're going to use this for is to determine what percentage of the table is coming back. If I have 10,000 pages in the table and I'm going to be reading 9,500 pages in order to use a particular index, it may be faster to scan the table than it is to bounce in and out of the index structure to bring all those pages back.